Hi, welcome to Inside Dev. Today we are going to talk about the three types of machine learning algorithms, how they work, what are their usage in the real world, and what issues we face while using them. So without further ado, let's get started. So what is machine learning? In short, machine learning is the ability to take data and use it to create a model. We can then use this model to infer the structures or properties of records. The current buzz environment is looking at machine learning as data in, magic out machines, able to do anything. This creates a lot of cases of unrealistic expectation and misuse in implementation. By understanding the premise of each type of machine learning, when to use it, and its limitation, we can start a meaningful conversation on how to implement this ability in the real world applications. So, this is why it's important to distinguish between the types of machine learning algorithms, because each type is helpful for certain kinds of problems and use different kind of data and vary in the insight you can get from it. The three types of machine learning algorithms are supervised learning, when we know what we are trying to infer, and we have data for the result. Unsupervised learning, when we don't know what we are trying to infer, or we know but we don't have enough data about the expected results. Reinforcement learning, when the environment changes by the action of the algorithm, like in games or robotics. So let's start by looking at each one in detail. So let's start with supervised learning. This is usually known as prediction algorithms. It will receive as an input data that for each record we know what is the expected result. For example, if we know a Mazda cost from 2016 cost $30,000 and a Mazda from 2017 cost $35,000, we can predict that a 2018 Mazda will cost $40,000. But supervised learning isn't limited to prediction of a value. You can use it to create custom service Q&A using data from customer support and to create a chatbot. Automatically tag social media using the user tagged data from the past, or even use it in image processing to identify the emotion a face is showing only by what people said they felt at that time. The limit of this approach is that each record needs to be labeled with the expected result. This is a problem when you don't have enough record on or no history. We don't know the result for each record. We don't know what we are looking for, or what we are looking for is a very rare event, like in a fraud detection. Now, let's look at unsupervised learning. To cope with the case we don't know what is the meaning of the data, or the data is not labeled, we can use unsupervised learning to understand the inner relationship between the properties of the data and find patterns in the data and anomalies that divert from those patterns. For example, on transaction data from supermarkets, we can discover that people who buy diapers also buy beers. We can also understand what characterizes the customer who buys beer. We can find anomalies in purchase. This can lead to finding fraud and misuse. This can give us insight, a lot of things about the data, but it lacks a few areas. There is no indication if a pattern or anomaly is good or bad. If something is an anomaly, it doesn't mean it's fraud. It just means it's different. Lots of false detection on anomaly and pattern recognition. The results can vary by the changing in model definition, like if we want to cluster between 5 groups and 10 groups. Now let's look at reinforcement learning. Reinforcement learning are the algorithms that know how to play chess, play Go, or Super Mario, and on the other hand can control robots and optimize store layout. The base of the algorithm works on the premise we can act on the environment and we get the result of our actions. For example, the robot moves and then it receives changes in GPS positioning. We put the diapers next to the beers and see if the sales change. We can try different strategies in game and to see if we win. Issues with reinforcement learnings are it requires an interactive environment or a simulation of that environment. Sometimes the knowledge of the result of the action are only partial. Sometimes the knowledge on the results of an action are only partial. This is called partially observed. Sometimes the result can be corrupted, like in case of faulty sensors. In conclusion, when we understand what we can achieve with each type of machine learning and we know what is required to make it work, the sky is the limit. Thank you for watching. If you have any questions or suggestions, please leave a comment or contact me at insidedevelopment@gmail.com.